Why airplanes don't use parachutes in emergencies, the truth explained. Imagine this for a second, a commercial airplane with hundreds of passengers flying at over 10,000 meters. And suddenly, in an emergency, a huge parachute opens and gently brings everything down to the ground. It sounds like a simple, almost obvious solution. After all, skydivers do this all the time. Equipment lands safely using parachutes. So why not use the same idea for airplanes? This is one of those questions that seems to make perfect sense until you look closer. The first thing that completely changes everything is size. We are not talking about one person or a light load. A commercial airplane can easily weigh more than 70, 100, or even 200 tons while flying. That changes everything because in physics, weight is not just a number, it is a constant force, pulling everything down with huge intensity. Now think about the parachute. To hold something that heavy in the air, it would need to create an equally massive resistance against the air, and that is only possible with a very large area, much bigger than any parachute you have ever seen. In reality, we are talking about something extremely large, not just a slightly bigger fabric, but something as big as an entire field, maybe even more. A parachute capable of holding an airplane would need to capture a massive amount of air, slowing down a huge moving mass. And here is something many people forget. The airplane is not still when the emergency happens. It is moving at very high speed. A commercial airplane in cruise can easily go over 800 kilometers per hour. This means that when any system is activated, it would have to deal not only with the weight of the airplane, but also with the energy of all that motion. And this is exactly where the idea starts to fall apart. Because opening a parachute in these conditions would not be smooth. It would be violent, brutal. The force created at the moment of deployment would be so strong that, instead of saving the airplane, it could simply destroy it in the air. If you have ever seen a parachute opening in slow motion, you know that even at relatively low speeds, the opening is not instant. It happens in stages to avoid a sudden impact. Now imagine multiplying that situation by dozens of times in speed and hundreds of times in mass. In the case of an airplane, there is no smooth opening that can fully compensate for this. If the parachute opens too fast, the deceleration force would be so extreme that the entire structure of the aircraft would suffer a violent shock. The fuselage, which is designed to handle pressure spread across the whole flight, would suddenly have to deal with a concentrated force pulling everything in one direction. It would be like the entire airplane being held in the air from a single point. And that is extremely dangerous. The wings could twist beyond their limits, attachment points could fail, and the structure itself could start breaking apart while still in the sky. Instead of slowing down safely, the airplane could disintegrate. But let's suppose that somehow this problem could be solved, and a system could be created to open gradually enough. Even then, another huge problem appears. Where would you put this parachute? Unlike what it looks like from the outside, the inside of an airplane is extremely optimized. Every centimeter of the fuselage has a specific function. There are cargo compartments, fuel tanks inside the wings, electrical systems, hydraulic systems, structural reinforcements, and of course, space for passengers. There is no extra space. Now try to imagine where you could store a parachute the size of a football field. It would not only take up a massive volume, but it would also require a complex deployment system with cables, release mechanisms, and structural reinforcements to handle the forces involved. And all of that would add weight. A lot of weight. And in aviation, weight is not just a technical detail, it is one of the most critical factors in the entire design. Every extra kilogram means more fuel, more engine effort, and less overall efficiency. Adding a system like this would not only reduce performance, but also create new risks. And then comes an even more important question. Even if all of this were possible, would it work in every situation? The answer to that last question is what really breaks the idea completely. No, it would not work in most real emergencies. Because, unlike what many people imagine, Problems in airplanes do not happen in perfect situations with plenty of time and ideal conditions. Many emergencies happen at critical moments, like during takeoff or landing, exactly when the airplane is closest to the ground. And that changes everything. For a parachute to work, it needs time, and most importantly, enough altitude to fully open and start creating drag against the air. Without that distance, it simply cannot work. Now imagine an airplane just seconds from the ground, descending to land, or climbing right after takeoff. If something happens there, there is not enough vertical space for a giant parachute to open, stabilize, and slow down that massive weight. In other words, at the most critical moments, it would be useless. But even at high altitudes, the situation is not as simple as it seems. Another important factor is the environment around the airplane. Turbulence, unstable air currents, and sudden pressure changes can completely affect how a large parachute behaves. Unlike a skydiver who has some flexibility and can adjust to movement, an airplane is a rigid, massive structure that is very sensitive to uneven forces. And this creates a risk that is not obvious, but extremely dangerous. Imagine the parachute does not open perfectly evenly. Even a small difference, one side inflating before the other, can create an uneven force. In a light object, this causes rotation. In an airplane, this could mean total loss of control. The aircraft could start spinning, tilting, or entering an uncontrolled motion, with no way for the pilots to fix it. And inside the cabin, it would be chaotic. Hundreds of people would be exposed to sudden side forces, sharp changes in angle, and possible internal impacts. Something that was supposed to be a safety solution would end up creating an even more unstable and dangerous situation. But here comes the twist that almost no one expects. Airplanes already have a much more effective way to deal with emergencies in the air. And it does not involve falling. The big turning point in this story is understanding that airplanes were not designed to fall safely. They were designed to keep flying, even when something goes wrong. And that changes everything. Unlike a normal object, an airplane does not rely only on its engines to stay in the air. What really keeps it flying are the wings. They are designed to turn movement through the air into constant lift, creating a force that balances the weight of the aircraft. This means that even if the engines completely stop, the airplane does not just fall. It glides. And this is not a short or uncontrolled glide. In many cases, a commercial airplane can travel dozens of kilometers just gliding through the air, with full control of direction and descent. It is like surfing on the airflow around it. This is something that surprises a lot of people, because intuitively, it feels like without engines the airplane would be lost. But in reality, the pilot still has control over the path, choosing where to land, adjusting speed, and even avoiding obstacles. Now compare this to a parachute. A parachute does slow things down, but it almost removes horizontal control. Movement becomes much more dependent on the wind than on the pilot's decisions. Instead of choosing exactly where to land, the airplane would be at the mercy of the environment. And that is a huge problem. Imagine an airplane slowly descending over a city, a mountain area, or even the ocean without precise control of direction. The risk of landing in a dangerous place would be extremely high. With working wings, even in a serious emergency, the pilot can guide the aircraft toward an airport, an improvised runway, or an open area with less risk. And there is something even more impressive. Modern airplanes are built with multiple redundant systems. This means that if one part fails, another takes over. Hydraulic, electrical, and control systems are duplicated or even triplicated to make sure the airplane keeps operating even in difficult situations. In other words, the engineering philosophy is not, what if it falls? But instead, how do we keep control? And that is exactly what makes parachutes not only impractical, but unnecessary. But there is still one interesting exception that seems to go against all of this. And that is where the story gets even more interesting. There is, in fact, a type of airplane that uses parachutes as an emergency system, and this may seem to contradict everything we have seen so far. But the difference is exactly in what these airplanes are. Small, light aircraft, often with only a few passengers, can be equipped with a system called a ballistic parachute. In this case, we are not talking about fabric opening slowly, but a system activated by a small rocket that literally pulls the parachute out of the aircraft in a fraction of a second. It is fast, direct, and it works. But it only works because the context is completely different. These airplanes weigh only a fraction of a commercial airplane. Their speed is also much lower. The forces involved, while still large, are much more manageable. And most importantly, the structure of the aircraft is designed from the beginning to handle this kind of concentrated force. Now try to scale this to an airplane that weighs hundreds of tons. The same system would require not only a massive parachute, but also an extremely powerful deployment mechanism, capable of handling much greater forces. This would create a dangerous side effect. The activation system itself could damage the aircraft structure at the moment it is triggered. And there is more. Even in small airplanes, the parachute does not guarantee a perfect landing. The aircraft does come down, but the impact with the ground can still be significant. The goal is not to completely avoid impact, but to increase the chances of survival. Now imagine a commercial airplane landing this way. Even with a giant parachute, the weight involved would make the final impact extremely strong. The structure might not absorb that energy safely, putting everyone on board at risk. In other words, a system that works well on a small scale starts to fail when scaled up. And this reveals a fundamental principle of engineering. Not every solution can simply be made bigger and still work the same way. Some ideas work at one level but become impossible at another completely different level. And in the case of commercial airplanes, the parachute does not just lose efficiency, it becomes an additional risk. But there is still one final point that completely closes this question. Because in the end, the question is not only, why not use parachutes? It is, why are airplanes so safe even without them? When you look at a modern airplane, it is easy to focus only on what you can see: wings, engines, fuselage. But the real secret of safety is hidden in something much less obvious: the way everything is designed to keep working even when parts fail. This is called redundancy. In simple terms, it means that almost everything important for flight does not exist only once. There are multiple versions of the same system, working together or ready to take over immediately if something goes wrong. Hydraulic systems, for example, which control parts like the rudder, flaps, and ailerons, are usually duplicated or even triplicated. If one line fails, another keeps working without the pilot losing control. The same happens with electrical systems, onboard computers, and even navigation instruments. Now compare this with a parachute. A parachute would be a single system, one activation moment, one chance to work perfectly. If something goes wrong, if it does not open correctly, if it tears or partially fails, there is no backup. And in aviation, relying on a single critical solution is exactly what engineers try to avoid. Another important point is that airplanes are designed to handle problems gradually, not with sudden extreme solutions. Instead of depending on one drastic action in a crisis, they allow the pilot to manage the situation, adjust settings, and make decisions based on what is still working. This gives time to change direction, to descend with control, to find a safe place to land. And time, in an emergency, is one of the most valuable things. Now compare this to activating a giant parachute. It would be an irreversible decision. Once activated, there is no going back, no way to adjust, correct, or adapt. The airplane would stop flying and start falling in a controlled way, but without real control. And this goes directly against the philosophy of modern aviation. Because flying with control, even in a difficult situation, is almost always safer than completely losing that control. And that is exactly why, instead of investing in safe falling systems, aerospace engineering has spent decades improving something much more powerful: the ability to keep flying, even when everything seems to go wrong. And now, all of this leads to a conclusion that completely changes how we see this idea. In the end, the idea of an airplane with a parachute feels intuitive because it comes from a simple logic. If something goes wrong, just slow down the fall. But in the real world of engineering, this logic not only fails, it becomes dangerous. Because an airplane is not just a heavy object in the air. It is an extremely complex machine designed to balance forces with precision, maintain control at high speed, and constantly react to the environment around it. Everything in it is built to keep working, under pressure, with failures, and even in unexpected situations. Adding a giant parachute does not solve these problems. It completely ignores how an airplane actually works. The scale makes it impractical. The speed makes deployment destructive. The structure is not designed for this kind of load. The lack of control during descent creates new risks. And most importantly, the nature of real emergencies prevents this system from working when it is needed the most. And then comes the most important realization. Airplanes already have their own form of active safety. They do not need to fall slowly, because most of the time, they do not fall at all. They keep flying. They glide when needed, avoid dangers, adjust their path, use redundant systems, and allow pilots to make decisions based on real control, not passive falling. And that is something far more powerful than any parachute could ever offer. In the end, the original question was not wrong. It was just incomplete. It is not that engineers never thought about using parachutes. They did. They tested. They analyzed. And they reached a clear conclusion. There is a better solution. A solution that does not depend on luck or a single critical moment, but on continuous control, applied physics, and highly refined engineering. And that is exactly what keeps airplanes safe every single day, flying across the sky with thousands of people on board. Now, when you look at an airplane flying, maybe the question is no longer, why doesn't it have a parachute? But instead, how does it keep flying even when everything seems to be against it?